All right, this video is for 7.3b, which is hyperbolas centered at HK, or not the origin. So that's the bottom two equations here. You have a vertical hyperbola, which means that it opens up and down if the y value in the equation comes first. And you have a horizontal, or opening left and right, if the x value in the equation comes first. And then a couple things to remember is that a squared always comes first in either one. So in the hyperbola, a squared is always on the left, the first value. And if x comes first, then it opens left and right. If y comes first, it opens up and down. One thing to note too is if it opens up and down, just be careful that your center is always HK. So the x coordinate actually comes second in the equation because the h is always with the x and the y is always with the k. So no matter what, your center is always HK. So just be careful if it is a vertical hyperbola that you get the x coordinate with the x and the y coordinate with the y. Whoops. All right. So here's our first example. So this one is going to open up and down because the y value comes first. And your center then will be, the h is going to be 3 and the k is going to be 9. So just what I was saying, the x value of your center always comes with the x parentheses. And then your a squared value will be 49, so a is going to be 7. B squared is 4, so b will be 2. A squared is always first. So then, since it opens up and down, and your a is 7, your vertices are going to be above and below 7 from the center. So your vertices will be 3, and then you're at 9, you need to go up 7, so 16, and then you're at 3 and you need to go down 7, so 2. So you're taking the 9 and you're adding and subtracting 7. So since I have a center of 3, 9 and vertices of 3, 16 and 3, 2, you're going to have to change your scale here. So I'm going to count by 2s to graph this. Counting by 2s, center of 3, 9 will be right here then. And then 3, 16 is going to be 7 up from that point. So 2, 4, 6, 7 up right here. So that should be 16. And then 7 below, 2, 4, 6, 7 below is at the point 3, 2. Counting by 2s, it looks like that. So those are your vertice points because the y comes first, it opens up and down. Now I need to graph my other 2 points to make the box. So I'm going to use the b value of b equals 2. So from your center, you're going to go over 2 and left 2, right 2 and left 2, and then use those 4 dots to make a box, because you need the box to make your asymptotes. Make sure your asymptote goes through your center and then the corner of your boxes. Through the center and through the corner of the box. So then you can draw your hyperbola. Now, since you have your vertices and your asymptotes drawn, you're going to use your vertice up here at 3, 16 and then your asymptotes to guide your drawing. Then the vertice down here at 3, 2 and then use the asymptotes to draw the hyperbola or guide that. So that it's a rather narrow hyperbola, especially more narrow because we're counting by 2s. So then to find the focus points, Since it's a hyperbola, the focus is defined to be the C value, the distance from the center to C, and you find C by doing a squared plus b squared equals c squared. So if the original equation is a minus, then when you find your focus, you do a squared plus b squared, which is different than the ellipse. So in this case, you're going to do 49 plus 4, which is 53. So c squared equals 53. So c equals the square root of 53. I'm going to grab a calculator real quick. So I know it's going to be just above 7. The square root of 53 is approximately 7.3. So that'll help me graph it. So from the center point, which was right here at 3, 9, you're going to go in the direction of the vertices, up 7.3 and then down 7.3. So about there on my picture. What that's going to look like as an ordered pair is that your focus, since it's a vertical, your focus point is not changing your x value, but your y value of 9 is increasing and decreasing by the square root of 53. So it looks like that. Which if you go back to the original equations, you can see the focus changes k plus or minus c. So the y value is the one that changes there. Okay, the equations of the asymptotes. So the asymptote is no longer centered at 0, 0. So I'm going to use point slope, where x1 and y1 is a point that the asymptotes go through. Both asymptotes go through the center point. So I'm going to use the center 3, 9 for my x1 and y1. And then the slope of each asymptote is rise over run. So it's always the y value over the x value. So it'd be slope of 7 over 2. And this one is a slope of negative 7 over 2. So slopes are both positive and negative 7 over 2. So the equation of the asymptote will be y minus 9, because that's my y coordinate, equals plus or minus 7 halves, and then x minus 3. So those are the two equations for my asymptote. And that one's done. Okay, example 2. Looks like I'm missing my fraction bars here, so I'll draw those in. So here the center is at -2, -3. The x value comes first, so this one will open left and right. So if I start with my center at -2, -3, then a squared is 16, so a equals 4, which means from your center, your vertices are going to be 4 to the right and 4 to the left from the center. So you can use your picture and see that that's at 2, -3, and 1, 2, 3, 4, 5, 6, -6, -3. So you can tell the picture right here, you can see that. I'm actually going to move this point off my graph, -6, -3. Remember that you can take your center point and it's moving the x coordinate, because the x, the 16 is under the x, and it's moving it by 4. So plus or minus 4 to the x coordinate, the y coordinate stays the same. If you do -2 plus 4, that's where I got 2, -3. -2 minus 4 is where I got -6, -3. So you can calculate it that way as well. So I'm going to finish graphing this by graphing my b values of 3. So from the center in the y direction, so up and down 3 from the center. And then I'm going to draw the box with those 4 points. And then through the center and the corners of the box, I'm going to draw the asymptote lines. So make sure you go through the corners and through the center. And this one opens right and left. So this is your vertice point at 2, -3, and you can use your asymptotes to draw your hyperbola. And then you have your -6, -3. Use your asymptotes to draw your hyperbola. Okay, to find the focus points, do a squared plus b squared equals c squared. So this one would be 16 plus 9 equals c squared. So c squared is 25, so c equals 5. So to the right, 5, and then to the left, 5. And those focus points, again, the x-coordinate is changing. And you can see this in your picture. It's 3, -2. And that's because -2 plus 5 is 3, and that's -3. So that's this point right here to the left of the hyperbola. And then if you do -2 minus 5, you're going to be at -7, -3. So those are my two focus points, the ones that I graphed in pink. The asymptotes, I'm going to use my center, -2, -3 as x1 and y1. And then my slope is rise of 3, so up 3 over 4. So slope is 3/4, both positive and -3/4. So the equation of the asymptotes, y minus -3 will actually be y plus 3. And then plus or minus 3/4, and then x plus 2, because that's x minus -2 is your other point. So this is in slope-intercept form. I mean point slope form, because I give you a point and the slope that the line has. And the point that it's on is -2, -3, which is the center. To keep this video a little shorter, I think I'm going to skip the third example in graphing and then write a couple equations. So I really think a picture helps to decipher this information. So I like to start with my vertices. So it's given my vertices, which are at 0, 2, so over 0, up 2, and 4, 2, so over 4, up 2. So if my vertices are right and left of each other, that means my hyperbola opens right and left. Which means that the equation that you're going to need will start with x. Be x minus h squared. A squared always comes first. Minus y minus k squared. And then over b squared equals 1. So it's your job to find A, B, and the center. If you know the two vertices, the distance between the two vertices is their major axis is 2A. Well, there's 4 between those two, which means that A equals 2. So A equals 2, A squared will equal 4. You can also use that A equals 2 to find your center, because if it's 2 for A, then it has to be right here. 2 to the left and 2 to the right would give me my vertices, so the center is right at 2, 2. Remember, you can always take the two vertice points and find halfway by adding the coordinates together and dividing by 2. So add the x's, divide by 2, add the y's, divide by 2. That's the center point, halfway between. Center is going to be 2, 2. That's my HK. Next, I'm also given my foci points. My focus points tell me my C value. So if I look at those -1, 2, and 5, 2, the distance from -1 to +5 is a distance of 6. From focus to focus is twice the value of C. So if 2C, the distance from the distance across is equal to 6, then C equals 3. Oops. C equals 3, which means that C squared will equal 9. I'll need that in a second. You can also count the distance from the center to the focus, and that's also just 1c. So the center to the focus is 3, from focus to focus is 2c. To find the rest of my information, since I have a and c, I'm going to need to use a squared plus b squared equals c squared. So that's going to be 2 squared plus b squared equals 3 squared, which really is 4 plus b squared equals 9. Solve for b squared by subtracting 4. So b squared equals 5. So I need that. B squared equals 5. So now I have everything I need. My HK will go into the equation right here and right here. A squared goes here, and B squared goes there. So final answer is x minus 2 squared over 4 minus y minus 2 squared over 5 equals 1. Okay, similar example. This time I don't give you a graph, so sketching a picture will have to do. Write the equation of a hyperbola with this information. This time my vertices are 5, 0, and 5, negative 4. Remember, my vertices are going to give me A, and then the center, the focus is going to give you C, and you can also find the center with the focus points too, because the center is halfway between either of those. So I'm just going to sketch a picture first. So 5, 0 is like right here, and then 5, negative 4 is here. So since these are up and down from each other, that means that the hyperbola opens up and down, which tells me that the y comes first. So it's y minus k squared over a squared minus x minus h squared over b squared equals 1.
Lydia, Dion, please come to the office. Lydia,
Sorry.
Dion, please come to the office.
Remember that the h always goes with the x, the k always goes with the y, and the a squared always comes first. Okay, I can find the distance between the two vertices. So from 5, 0 to 5, negative 4, that's a distance of 4, which means that 2a equals 4, so a equals 2. Then the distance from the focus points, like the point 5, 2 and 5, negative 6, that's 2 above here plus 6 more. That is a total distance of 8. So twice the value of c is equal to 8. So 1c is equal to 4. The center is halfway between all of this stuff. So right here, you can figure that out by either adding the coordinates together and dividing by 2. So for example, since the 5 is not changing in any of these, you know that your center will be 5 something. Then you can take your coordinates, like 0 plus 4 is negative 4. Negative 4 divided by 2 is negative 2. Or you could use your focus. 2 plus negative 6 is negative 4. Negative 4 divided by 2 is negative 2. Or you can use your picture. Halfway between these two is the point 5, negative 2. So lots of different ways to find your center. HK. Again, I only have A and I only have C, so I will need to solve for B. So a squared plus b squared equals c squared in a hyperbola. So 2 squared plus b squared equals 4 squared. So 4 plus b squared equals 16. So b squared equals 12 if I subtract 4 on both sides. All right, final answer. Y minus k, make sure you use k with y. So it'll be y plus 2 squared over a squared. A was 2, so over 4. Minus x minus h, which is 5 squared over b squared, which was 12. And that is equal to 1. Okay, that's all. Come see me if you still need help. Thanks for watching.